No talking in the classroom. All right, that's great. Thank you. Well, it's my pleasure to introduce the moderator for this next session, focusing on PCBs and communication. It's Laura Tam, who is one of the newer members of the RMP family, and she comes to us now as the executive director of the Bay Planning Coalition, a key partner in the collaborative spirit of the region. And I know what's very noteworthy about her bio is that she has 25 years of experience building partnerships to advance resource policy, climate resilience, and healthy places. And definitely passionate about building consensus and getting organizations to work together. So come on up, Laura.
Thank you, Tom. So many years of experience there with the RMP. I am one of the newest people. I've been part of the RMP steering committee for less than a year, but it's been really fun and so inspiring to be among this community of scientists. I was sampling stormwater myself for my grad school project 25 years ago, so I feel very heartwarmed by the previous panel, in addition to inspired by hearing from Tom the sort of warm remembrance of people who have passed this year, as well as from Matt making modeling accessible, to Don making stormwater funny, and Ezra making non-target analysis seem so cool and so innovative, like what this program has been doing for 25 years. So thank you for inviting me to moderate. I've learned a lot from RMP colleagues this year, from long-timers who've been stewarding this project for so many innovative science monitoring and policy for years. One thing I've learned, and I know we're not going to talk as much about sediment as we were going to, because one of our federal colleagues unfortunately couldn't be here today, but one thing I've learned, and many of my people in Bay Planning Coalition participate in the sediment working group of the RMP, is that it is very important and challenging and expensive to move sediment around to the places that we need it for beneficial reuse. We'll hear more about this from Xavier today. Another thing is that the quality of the sediment and what you can use it for need to match. Much of my career has been in policy and advocacy, where it can be all too easy to say what should be done and who should do it and why. But it is another thing to have a specific idea, fund it, permit it, monitor it, and implement it and replicate that, or maybe if you're lucky, watch others replicate it. And today we're going to hear about a couple of such specific ideas, pilots, innovations, including regulatory innovation that's going on here in the Bay with issues of contamination, sediment placement, and communications, thanks to Sierra, who has stepped in to join the panel. Finally, last week, BPC, my organization, held its annual Dredging and Beneficial Reuse workshop. Some of you may have been there. We heard from Dr. Todd Bridges, formerly of the Engineering with Nature program at the U.S. Army Corps of Engineers, who gave our region a less than wonderful grade on how we're doing at innovation, not that we asked to be graded. He challenged us to do better on improving background conditions. I don't know if he's familiar with the RMP as he should be, but he did say that, for example, the Army Corps of Engineers has established a 70% beneficial reuse goal by 2030 that was codified in the 2024 Water Resources Development Act. And he asked and challenged us all, what are you doing in your organization to accelerate innovation? And what can we all do together to accelerate innovation? So we're going to hear about that today. So I would like to introduce our panel. First, Xavier Fernandez leads the San Francisco Bay Regional Water Quality Control Board's Planning Division, where he is responsible for overseeing policy development, ambient water quality monitoring, and navigational dredging permitting. He's also very involved with the Water Board's Climate Action Initiative and providing regulatory guidance to internal and external parties on permitting of climate adaptation projects and beneficial reuse of sediment. After Javier's presentation, we're going to hear from Sam McWilliams. He's the Technical Director of Integral Consulting's Marine Science and Engineering practice. He leads an incredible team of practitioners to address problems in marine ecosystems with a focus on hydrodynamic sediment transport and the collection of data to support site evaluations. Last but not least, we're going to hear from Sierra Garcia, who joined SFEI's Clean Water Program this spring as the Institute's first full-time science communicator, with a focus on supporting communications for the RMP. So I'm going to turn it over to Xavier for our first presentation.
Good morning, everyone. Thank you. First of all, I'd like to have a special thank you for Don Yee for wearing his Hawaiian shirt. I was thinking of wearing a sport coat, and I decided no one would recognize me, so here I am. Today, I'm going to talk about the Water Board's activities related to beneficial reuse or beneficial use. The last time I gave a talk like this was in 2020. Which is why I decided to volunteer and give it again, because I figured 5 years, you know, stuff has happened. It's time to give it again. So some of the recent efforts that we've done. First of all, in this talk, I'm going to cover what the sediment needs are and sources. Essentially, how much do we need and where can we get it? Then I'm going to talk about an innovative project that we worked with the Army Corps of Engineers on. It's called the 50-50 split, the Oakland Pilot Project. Then I'm going to move on to another project that we partnered with the Army Corps on, which is the strategic placement, which is over at Eden Landing. And then the last two things I'm going to talk about is the refuse master quap, which was more recent, as well as looking at upland and flood control sources and working with SFEI to fill some data gaps. And then I'm going to conclude with a little more forward-thinking, you know, what are we doing moving forward? What's coming up for water board activities? First, sediment needs and sources. This comes from the 2021 Sediment for Survival report that SFEI put together. And essentially it concluded that we needed a lot of sediment in order to restore our marshes and to adapt them to climate change so that they could be resilient. About 550 million metric tons. And a lot of this can be provided by natural resources, but not enough. And I think it's roughly about a third can be provided by natural sources. So we have to find other sources of sediment. And looking at other sources of sediment, the report found that 60% could be provided by navigational dredging. So that tells me we need a boatload of sediment, right? Scow loads of sediment. In addition, it looked at flood control channels, and it was about 5%, but it only looked at tidal portions of flood control channels. And so if you look upstream, there's even more sediment. So I would say there's likely more than 5% of sediment that we need in flood control channels. Then it looked at upland sources. Upland sources come from excavation for development and redevelopment, and that can provide roughly 30% of the sediment we need. So we're right there, we're close, right? We're already over 95% of what we need. And then lastly, 20% is trapped behind dams. The Water Board is currently focused on the first three and not as much on what's trapped behind dams at the moment. Doesn't mean that we won't eventually get there, but looking at the first three, getting us to pretty close to 100%, we decided those were the sources that we had the most regulatory control on, the most way to influence and increase beneficial use. And next, I'll talk about some of the activities that we've done related to these sources. In the navigational dredging realm, we worked with the Army Corps to come up with this idea of a 50-50 split project. So what is the 50-50 split? The Army Corps has their regulatory requirements, their rules, which essentially says that it has to be the least cost alternative. And so that has been a real challenge for us because a lot of the sediment from Oakland, which is somewhere between 600 and 1 million cubic yards per year, has been going to deep ocean because that's the least cost alternative that meets environmental goals. But we thought, well, why don't we allow the Army Corps to put half of it in the bay if they send the other half to beneficial use? Would the cost, because beneficial use costs roughly 3 times in bay disposal, and deep ocean costs roughly 2 times in bay. So if we go 50-50, that kind of splits the difference, right? And then maybe we'll get the least cost to be 50% in bay, but 50% beneficial use. Well, this was new and innovative for the LTMS and DMMO, and it took quite a bit of negotiation and a lot of meetings with the DMMO to get everybody on board with being comfortable with this and making sure that they didn't exceed any thresholds for in-bay disposal. But we were able to get it done. And so in 2021, the Army Corps was able, the other part was the contracting part. And if you ever worked with the Corps and you want to talk contracting, I'm there for you. We can have a beer, we can cry over it. But they were able to get the contracting to work out. And so of the 800,000 cubic yards that they dredged in 2021, about 450,000 cubic yards went to beneficial use. This is incredible. It could have been 800,000 cubic yards going to deep ocean. With this plan, though, 450 went to beneficial use and 350 got put in bay where it still remained in the system. It'll probably end up in the flood control or in the navigational dredging channels again, and then they can dredge it out again. Maybe they could send it to beneficial use. The other thing we found was that it led to some interesting developments. Historically, we've had one offloader. So there's been one dredger that had one offloader in the bay. Then a second one came on board for Cullinan. So we had 2 offloaders, and this has always been sort of a challenge. And one of them is union, one of them's non-union, and so you can't go here, you can't go there, depending on who's doing what. Well, with this development, there were actually 2 more dredgers that built their own offloaders. So it doubled in 1 year. I mean, we've been trying to get all the dredgers to build offloaders for years and years and years. In 1 year, we got a double. So now we have 4 offloaders in the bay, which hopefully will help to reduce costs over time. The next project I'm going to talk about is the strategic placement project. This was also a project that we partnered with the Corps. We were the CEQA lead, which we always enjoy being. Essentially, we're the only state or local agency that has any authority over the Corps, thanks to a waiver of sovereign immunity under Clean Water Act. And so we had the joy of being the CEQA lead. We did a combined document. We did an EA FONSI and a mitigated neg deck in order to move this forward. And what they did with this project was they took sediment from the Port of Redwood City, and they took it and they got as close to the shore as possible. And I wish Jessie Lacey could have been here because she would have talked a bit more about this. And they placed the sediment as close to shore as possible, and then they let natural waves and currents carry it to shore and feed the marshes. There was some concern over some of the eelgrass and whether turbidity would impact the eelgrass. There's also concerns about the benthic community and how fast it would recover. And folks were also kind of wondering, like, will this even work? Is the sediment really going to go towards the shore? I mean, there's a lot of there have been a lot of projects on the outer coast with sand and that have shown with beach nourishment that this does work. So the water board was pretty confident that it would work, but there were questions around it. So what they found, because they did a year of monitoring following the placement, which happened in December 2023, and they found that the eelgrass was undisturbed and there was a spike in turbidity, but it was really within the natural limits, natural variability that you see in turbidity in the bay. They also found, they thought they were going to put the sediment in like this pancake form and just kind of layer a pancake and maybe like a 7-layer cake or something. Well, that didn't happen. What ended up happening was they ended up having to place the material, ended up in these mounds. And what they found was that the mounds started eroding immediately. And the taller the mounds were, the more erosion, the faster the erosion. The shorter mounds were, then less erosion. They also did some tracer studies and they found that it did get to the marsh. The other thing they looked at was the biota, because there was concern about the benthic community as a food resource and what would happen with them. And after a year, they did find that there were a lot of early colonizers that colonized in the sediment. There were a lot of amphipods. So the numbers of organisms were equivalent to before, but they were different types of organisms. It wasn't as diverse, and it's not quite as good a food resource as the more mature. So amphipods don't have as much calories and nutrients as like clams, bivalves. Unfortunately, they only had a year funding for a year of monitoring. So that's one area where I think in the future we would look to try and figure out how we can get additional monitoring. Perhaps the Bay RMP can step in and do more monitoring, because we would really like to know how long it takes for this benthic community to recover so that it can provide food resources for fish. Then in 2024, moving on to upland soils, it started in 2023, but we finalized it in November 2024. We worked with the Fish and Wildlife Service on the Wildlife Refuge Quality Assurance Project Plan, or QAP, and looking at soil screening and updating, it says here statistical methods. I would actually say it's more risk methodology. And we incorporated things like the 95th upper confidence level of the mean. So rather than take point samples and compare to screening criteria, we are allowing them to look at all the samples together and take the 95th upper confidence level, the 95 UCL of the mean. And the reason why we allowed them to use that as a comparison to screening levels is because when you think about exposure across a marsh to ecological receptors, you're really talking about populations. And so you're not as worried about any sort of point source. You don't want to be screaming hot. So there are upper confidence, or there's upper limits that we won't allow. But you're really looking at exposure across the landscape as opposed to sort of single point exposures. The other thing that we worked on was a mean hazard quotient approach. So if you take the, I'll probably get this backwards, I always do this. If you take the concentration in the sample and you divide it by the screening level, if it's less than 1, then you're good, because that means that your measured concentration is less than your screen level. Sometimes though, we were finding that it would slightly exceed the screening level. And then we'd go through this whole process of looking at it and deciding whether it was okay. And so we decided, well, one approach that we've seen for risk assessment is to take all those hazard quotients and then take the average of those average quotients. And if that's less than 1, then it's okay. And the theory behind that is the thresholds are really based on exposure to multiple chemicals. A lot of the toxicity numbers are from studies where there were multiple, they're in situ studies. there wasn't ever just a single chemical. So this is a way to kind of account for that. There are some safeguards. There is some upper threshold limits that they can't exceed. There's also we can only use it for non-bioaccumulative substances. And then there's two new things that are included in there more as pilot studies. One is the cumulative weighted average, and that is because we're trying to encourage people to use their sites to maybe stockpile ahead of time. And if you have stockpiles and then you grade it and you mix it all around, you know, you can actually get a lower concentration through mixing. I don't like to call it dilution because dilution to me is like a liquid. This is mixing. And then we also looked at VOC reductions. There's a pilot study where they can look at that and they can get samples ahead of time and then measure it at the site. But there's more there, and I'll talk about that in a sec. The other project that we worked out in partnership with San Francisco Estuary Institute, we provided a little bit of funding. EPA provided a lot of money. Thank you, Luisa. And it's really the Sediment Solutions Project, and it's really watershed, going through watershed assessments. It's looking at marsh reconnections, creek marsh reconnections. It's looking at future conditions and really modeling the hydrology and the sediment. So far, the watershed assessments that were done have been completed. Is the Petaluma River. That has been completed, so they've identified sources of sediment and potential places where it can be used for restoration. San Tomas Aquino down in Santa Clara is currently in progress. And then there's two creek to marsh reconnections, Adobe Creek and Ream Creek, that are also being worked on. So moving forward, with my 1 minute remaining, I'm going to cover this. And we hired somebody, Alex Snyder, again with funding from the SFA program from EPA. We were able to get somebody who is focused on incentivizing beneficial reuse. That's the take home here. If you see Alex, he's somewhere here, say hello to him. He's going to be updating our beneficial reuse guidance. Our beneficial reuse guidance was from 2000. So it's about time. 25 years is generally a good time period for for updating things. Maybe a little more often might be better, but we're going to use. We're also going to either include or write a whole separate one. We haven't decided yet for upland. So the original guidance was just for dredge material. And then we continue to work on the quality assurance project plans. We're finding that there's updates that still need to be done. And then we are also working on a basin plan amendment. We've just started it. We're considering increasing the threshold. We have a trigger in our basin plan for when we look at allocations. And we want to look to see if we can increase it. And we're also talking with BCDC, seeing if they can increase their limit. We also want to look at hydraulic dredging and see if there's portions of the bay at times of the year where we can be okay with that in order to increase beneficial use. There has to be some sort of nexus with beneficial use. And then we want to continue the strategic placement pilot studies with Army Corps. And the next one I think is being looked at is Emeryville Crescent. And hopefully we can get funding to do more studies for a longer period of time. With that, I have no time remaining. Thank you.
Thanks, Xavier. You mentioned there was like a tracer study with a strategic placement thing. Was it just kind of presence absence or sort of quantifying how much ended up on the marsh versus in the bay or anything like that?
We're using models a lot for to quantify. I think it was more presence absence. I mean, we're just happy it got on the bay. It got on the on the marsh. I mean, honestly, there was some question of that and concern, and there have been projects called failures because, like at Ocean Beach, the sand ended up on the wrong end of the beach, and I'm like, well, it ended up on the beach. Let's be happy. After. We'll save it for after.
Hello, I'm Sam McWilliams. I'm happy to be here today to talk to you about a project we've been working on at Integral Consulting in conjunction with the incredible team at SFEI. My colleagues Craig Jones and Kara Shui couldn't be here today, so I get the honors of presenting what we've been working on. We've been working with Jay Davis, Don Yee, Pedro, Lester, quite a few others throughout this process, so you'll see some fruits of this labor. So I want to start by just really kind of framing the questions that we are trying to answer. So what are the rates of recovery in San Leandro Bay from PCB concentrations? We know that there are PCBs coming into this site. We know that it's been happening for a long time. It's in the sediment. At what point could we see some positive trajectory? What would be the impact of focused management of PMU watersheds? So PCBs come from upland sources. They're not naturally occurring, as we all know, and so they have to come from somewhere. If we can identify those and limit their exposure to the watershed, can we see some benefits there? And then what would be the impact of managing in-bay contaminated sites, both within San Leandro Bay and at a regional scale? So the idea here is that the thrust of this project is not just to look at San Leandro Bay, but really tie this back into the bay-wide valuations, what's coming in and how can we help to evaluate TMDLs and the new, I think those are going to be updated in the next few years. So how can we help to evaluate what's going to be going on bay-wide? So like I said, the long-term objective is to reduce PCBs in the bay. This is a multi-year project, really trying to use an iterative and adaptive approach. So as we get more information, we can put that back into the system and understand more about what's going on. We started with the focus of these priority management units, or priority margin units, excuse me, for a number of reasons. But the biggest being that that's kind of where the PCBs are. So we want to start our focus there. And like I said, this will really help us to tie back into that evaluations of the TMDLs that are ongoing. And I want to show that the figure that I have up on the screen is an example of lots and lots of data that's been collected since the mid-90s and through parts of the RMP. And you can see here that the largest concentrations are really on the margins, and that's because they're coming from the watersheds and they end up there. So one of the key parts of this process is to really understand the pathways of PCBs. I think that's been alluded to in a few other talks. Understanding how the watersheds are feeding into the bay, and all of these different pathways involve some complex processes. One of the key understandings or assumptions that we're making in this study, and I think it's well founded in science, is that PCBs are well tied to sediment. And so if we can understand the fate of sediment, we can understand to a large degree the fate of the PCBs. We want to make sure that we are evaluating or understanding the different processes that are going into that, to those pathways. So in the watersheds, how are PCBs getting into those channels? When they're there, what is causing them to erode or to be suspended? When they get into the marshes, are they interacting with waves, currents? How and when does that deposition happen? And part of this process is being able to isolate individual processes or a small number of them and really understand how they impact sediment fate and transport. So why San Leandro Bay? There's a number of sites in San Francisco Bay that have PCBs. San Leandro Bay is of high interest to a number of managers. There are known sources nearby. There are loads continuing to go into San Leandro Bay. The nice thing about San Leandro Bay, though, is that it's a little bit isolated. So San Leandro Bay, for those of you who don't know, is at the southern end of the island of Alameda. There are a number of watersheds that tie into San Leandro Bay. It's connected to the bay by two different connections to the wider bay, both at the bay mouth and then through the Oakland Estuary, but it is relatively contained. It also has a limited wave action, which is a key process that helps to resuspend and move sediment around in the wider bay. But if we can remove that from consideration in this case, it gives us one less thing we have to worry about. There's also evidence of accretion over time that limits the amount of bed processes and bed erosion that we have to evaluate. Number of well-defined inputs. Matt did a great job kind of keying this up, talking about the watershed. We know that these chemicals are coming into the watersheds, and this is we were able to improve or redefine some of the sub-embayments in the watershed to look at individual inputs at each of those blue lines that you see here in the bay. There's also just a wealth of data that's been collected at this site from SFEI and others, and so it seemed like the perfect place to kind of focus our efforts to start with. So our approach in modeling San Leandro Bay, and we're going to be talking about some models here in a second, is to develop a suite of models. There's no one model that rules them all. Matt did a good job, showed us watershed, hydrodynamics, to sediment fate. So we'll be talking about a few of those. We need to integrate the data that's available. So the pieces that from the watershed, discharge and whatnot, sediment loads. We want to be able to evaluate a range of loading scenarios. And I think this gets to the point about uncertainty that was brought up earlier. We can't predict the future, so we want to be able to evaluate what's going to happen. We want to be able to evaluate a number of scenarios that could happen and give us confidence that we have a range that we can work in. A part of this study is that we were able to track sediment from each of these different sources. So we have a number of sources from the watersheds, from the bay, from the initial sediment bed. So we can track each one of those individually and look at a composition of where those end up, and then ultimately tie that into an estimate of recovery rates. So there were three models that we're really focused on developing for San Leandro Bay. Again, the watershed dynamic model, that provides us estimates of discharges and sediment loads. We have a hydrodynamics model that provides water levels, currents, and bottom forces. The watershed dynamic model you can see up on the right was delineated by a number of smaller watersheds and updated to hourly outputs. The graph that we have on the page here is one water year, 2017, which was considered a wet year. And so the watershed dynamic model is providing us hourly inputs of how much water is coming into each of those watersheds and the amount of sediment that's associated. Again, this idea that the sediment is associated with the PCBs. The hydrodynamics model gives us an estimate of water levels, so the tidal exchanges with the wider bay, currents that are moving around in the system that could be redistributing those sediments, and then an estimate of bottom forces. And so the bottom forces are really what manage or modulate how much sediment might be deposited, or in a certain storm scenario, might be resuspended and then redistributed. We also have a sediment transport model, so we're actually modeling individual sediment, individual size classes. So we have a sediment is made up of lots of different size classes, some clays, silts, sands. We want to make sure that we're representing those size classes appropriately. They all have their own individual dynamics and move at different times. And the final thing is that this model helps us to evaluate sediment deposition. So where does the sediment ultimately end up? So in the loading scenarios and source tracking idea here, you can see the 4-panel plot on the left is an estimate of where each of these sources sediment ends up after a year. And so I think it makes kind of sense. East Creek is at the northeast end of the bay near Alameda Channel. The bright areas there are associated with sediment coming out of that creek, and that makes sense. Sediment's depositing near that watershed. Same thing is true for San Leandro Creek or sediment from the bay. The largest concentrations of material from those inputs are near where they come into the system. We also want to be able to tie that sediment to estimates of PCBs. And so there's been previous sampling done to get us estimates of what the concentrations of PCBs in the water column are, the PCBs associated with those sediment loads. And so we have a range of estimates. The best estimates for a few watersheds are bolded there. But between these two, we can then look at contaminant concentrations in the sediment bed. And so bedded sediment concentration is a function of what's already there plus what might be accumulated over time. And so what we're doing is we're tracking the upper 15 centimeters of sediment in the modeling. And that 15 centimeters is representative of the bioactive layer. There's some research behind that, but really where are the critters really working their way in and out of the sediment bed and being exposed to some of these materials. So again, this idea that we can look at individual sources and look at how all of those contribute to concentrations on the bed. So really what we're trying to do is understand recovery rates, and we're trying to project out 10, 15, 20 years. What could the concentrations look like over time? And so we've modeled a couple of different water years, looking at different dry, wet, average scenarios, and combined those over a number of different ways, but really looking at what could happen if we reduce concentrations in certain watersheds. So if we reduce PCBs coming out of East Creek, let's say, what might happen. And so Peralta North Mudflat and Peralta South Mudflat are the two mudflats near East Creek that we've labeled here on the figure on the left and the top and the upper portion of the figure. And we can see that changes to concentrations decrease, changes to concentrations that are coming in from the watersheds decrease the sediment concentrations over time. Some have different impacts on that. The same thing could be seen for Damon Slough mudflats. And so really here we can identify specific locations to look at recovery rates and say, what is the influence of a specific watershed on a specific site, which is great, because then we can say, if we clean up the sediment coming out of East Creek, we could see this potential reduction. We can also do this on a PMU-wide scale. We want to be able to do this to understand. It's great to have an individual watershed, but really we're looking at the system as a whole. And so what we've done here is looking at changing the concentrations coming in from each of those watersheds and saying, what does a 50% load reduction look like? What does a completely zero PCBs coming in reduction look like? That might be a little bit pie in the sky, but it gives us a good range and of understanding of what those impacts and the sensitivity of the system is to this, to these actions. And so from this, we have a number of lessons learned. And again, these lessons are really here for us to be able to apply them to the wider bay modeling that's ongoing. Sediment and contaminant retention varies by location. I think we saw that with in a couple of those graphs that says, depending on which watershed we remediate, we'll see a difference in response. Sediment quality influences recovery trajectories. So how much of the contamination are we reducing will impact those recovery rates. And then monitoring and model validation are essential for regional scalability. And so having an understanding of how accurate our models are, how confident we are in those models, will really drive whether or not we can take these lessons and apply them to other sites within the bay. And so that leads me to the next part of our talk, which is the optics study. And so Matt alluded to this a little bit earlier, where we went out and we collected a lot of data. Some of the modeling assumptions that we had built on, we wanted to see if those were correct. So what are the loadings that we are inputting into the bay appropriate? And so really what we're trying to do with this study is understand the sediment flux into and out of the system. San Leandro Bay is a great little control volume. We can really see, if we can monitor or measure all of the inputs coming in and out, we have a sense of what's leaving, what's coming, and what's staying in the system. This also helps to address some of the data gaps that we identified during the modeling work. What are the local currents? How do the local currents move around in the system? And then really help to corroborate the discharge and loadings coming out of the watershed model. So from last December until April of this year, we went out and did a large study where we deployed 7 platforms and collected a number of discrete samples. So 170 surface water PCB samples, 170 total suspended solid samples. So that gets us estimates of concentration at each of those input locations and the amount of sediment that is in the system. We have what I call something in betweens, which are sediment trap jars, which Don Yee led, passive PCB samplers provided by Stanford, and discharge transects using a cool little robot boat that we have on screen called Bob, who helped us collect discharge transects. We also collected time series of a number of water quality parameters, turbidity, chlorophyll, DO, current velocity and direction, salinity and temp, so on and so forth. So these data connections, really what we can get from this is from the hydrodynamics platforms and the ADCP transects, we can get discharges and flow rates. So that gets us what's the amount of water that's coming into the system or being exchanged in the system. We have TSS samples and discharge, which gives us time resolved sediment flux. So that's how much sediment is coming in and out of the system. And then we tie all those in with the optics analysis, which really then can combine to give us a time resolved PCB flux. So discharges provide estimates of loadings. Again, this kind of comes back to the watershed model. We want to make sure that those inputs are correct and give us confidence that those data are appropriate. We have these for each of those sites. I won't go into too much detail, but one you'll notice here, I just want to make this note that there is a couple gaps in these data sets. That's actually due to the amount of trash that's out in the site, and during these big storm events, we actually had a few instances where a blanket or some sort of debris fell on our instrumentation platform. But even given that, we still have some great data to be able to corroborate some of the models, look at how much is coming in into the system. The PCB concentrations, I think, are maybe something that's really interesting to folks. We have a wide range of PCB concentrations in those sediment samples here, or in the water column samples, but we were able to get those at each of those loading areas. And the key here is that when we compare that with our initial estimates that we were using in the model, so going back and saying, is the model representative of what's going on in the system? Yes. So the average high and low limits that we had in the modeling or exercises line up pretty well with the range of samples that we took in this study, giving us some of that confidence. So next steps, next week, phase 2 of this report will be published, outlining more of the details about how we're doing this analysis. By November 31st, we'll have a draft of the optics report. So that will include all of the evaluations of the optics data and those PCB loadings into the system, as well as a sed film erosion study looking at mobility potential. And then in Q1 of next year, we'll revise some of the San Leandro modeling, incorporating that optics data. And with that, I believe I'm out of time.
Thanks very much, Sam. That was a lot to fit in. I think you had a big challenge in terms of how do I do this in this amount of time? Regarding the optics, I think I'm very excited about adding this to the toolkit for the RMP because it's sort of like the analog or the extension of a way we've approached stormwater loads using optical backscatter probes and the turbidity surrogate method. And this is kind of the application to that on steroids to the bay. I wonder if you could, so San Leandro Bay is really favorable in terms of the morphology where these inputs are channelized, and so you can do your instrumentation and have pretty good confidence that the data you're getting are representative of that input.
Yeah.
But we've got other priority margin unit areas that aren't like that. The exposure to the bay is more open. And so presumably you and your colleagues have dealt with that kind of morphology in other circumstances. And so could you speak briefly to how you approach that kind of a challenge with instrumentation when it's not so confined like that?
Yeah, you're absolutely right that the other margin units are going to pose a little bit of a different challenge. I think the goal is to try to find locations that are as much as possible sheltered, so we have a clear definition of what's going on. It might be the case that not all tools are applicable at all sites, and I think that's something that we should definitely acknowledge. But we have done these types of studies in the center bay of San Francisco Bay, for example. And so I think that there's some opportunities to learn from those lessons, and maybe some of those limitations. I am by no means the expert on all the data collection side of things, so I don't want to speak for some of my colleagues who might say, oh, that's easy. But I think that there's a way to take some of that data and extrapolate it out if needed. Maybe just simplifying only a certain number of parameters to try not to conflate things could be one option. But yeah, it's certainly something that we have to be conscious of. No time. We'll save it for later.
I am the last person standing between everybody and lunch. And to get us started, I would love if folks have a smartphone available to quickly go to this very simple, not a survey, but we're going to pull up another screen in just a moment. So if you're slow getting your phone out, you'll have another chance to scan it.
Okay, I think you're good on.
And then when I want to get it back. Okay, I'm seeing a lot of collaboration, informative, awesome. I like that one's really big up there. Interesting, cutting edge is getting pretty big. So let's transition back to the main program. So feel free to keep adding things if you haven't yet had a chance to. Thanks, Martin. I am not here to talk about more sediment. I am a science communicator, and I asked you all to do that exercise with me just now so that we could start thinking about this fundamental question of what is the RMP about? What is our story? And we've heard a lot of versions of that in some of the science and data that we already learned about today. We have stories of complex decline and recovery of the bay in some of our contaminants, such as flame retardants that were successfully diminished by successful regulation, in that even though there are now newer generation flame retardants that we have to be concerned about. We have stories about the process of science and surprises that are found, and about, of course, lots of collaboration and innovation, like we saw with stormwater samplers. And we have this singular, this is the main purpose of the RMP. This is the big goal, and it is the first thing on our website if you navigate to the page. And I am focusing on this part of it, communicating information, which I think that a lot of us as scientists do by sharing data, publishing peer-reviewed papers, presenting at conferences, and everyone in this room is very well aware that giving access to the data alone is not sufficient to communicate information. A lot of that really depends on doing a good job of framing how we communicate. I'm going to take folks on a little rabbit hole down to some jargon about the science of science communication, which is a big reason why it's not sufficient to just give people accurate information and data about scientific issues, which is called the information deficit model. And this is a concept that assumes that audiences that science is communicated to are Squidward. They are going to set aside everything else and then just plug the new information in like a computer. And we have found time and again that this is not how human brains work. And so a less cartoony way of putting that is that this assumes that non-scientific audiences are in some senses empty vessels suffering from a deficit of scientific knowledge. And when studies have put this to the test time and again, trying to expose people to information and then see how well it is retained and integrated and interpreted, we find that people are actually, all of us, not just non-scientists, but everybody in the world from being human, will interpret new information through a lens of how they already understand the world and will be selectively remembering some of it. And so it is actually a really complex endeavor to get science accurately communicated. And I'm sure you all are saying, yes, I know this. This is something that that frustrates me, that challenges me. And I think that with the current state of the world and our country, something that is actually a pretty pleasant surprise is that within less than the last year, 3 out of 4 Americans still have a lot of confidence in scientists to act in the public's best interest. And the same survey also found that a majority of Americans describe scientists as poor communicators. So when I'm starting off this discussion of our communication strategy with the stories of what we do, not because the specific facts and data are unimportant, it's because they are critically important and people want to know about them and trust scientists overall, for the most part still, to be effective at finding that information, but are struggling to bridge that connection. So for a little bit of a history lesson on how the RMP has thought about this issue in the past, we were born, and then pretty soon after, scientists at the RMP had the foresight to think early on about information getting beyond the folks that are producing it and that have the PhDs necessary to understand the first corners. So the first Pulse of the Bay, a publication that is designed to be able to reach broader audiences, was produced quite early on in the program. And then it was 15 years later that there was a formal communication strategy developed, which went through a couple of tweaks in 2023. And there was a pretty good vision set up, outlined for communicating RMP science, but a lack of staff capacity to focus on implementing it. And then earlier this year, my role was brought on board for the first time. And I am responsible at the RMP for dedicating a large portion of my hours to focusing and thinking about RMP science in particular. So revisiting this goal and thinking about a strategy about how we do our communications, one of the first questions is to whom are we communicating, because this doesn't really specify. And thinking about audiences is something that is also driven by this other part, supporting management decisions. And so, of course, a primary audience has to be all of you, many people in this room, folks that are participating in the RMP, and there was a recognition at this stage that there are people so engaged and so involved and really just very much in the loop. and also RMP stakeholders and participants that might not be quite so enthusiastic about every bit of our science, and it might need a little bit more effort to reach. There were also considerations for other folks that are not stakeholders that still might be important to have our science reach. That includes, of course, other managers that are not specifically RMP stakeholders or on the water boards, but we also have policymakers, other groups of scientists, as well as the media, the public. I don't like the term the general public because there are actually many general publics. I don't think it's just one group. Potential funders of being able to supplement with additional studies. And I'm going to revisit this question of audiences a little bit later on in the presentation. These baselines, you could also break down each of these groups into so many other subgroups and think about what all of them need. And there is a lot of work to be done in thinking about what the value is of trying to get our science to reach these different groups. And that's something I'm going to come back to shortly. The original strategy also answered this question of how are we communicating the information? And so we have a lot of different ways that folks can engage. This meeting is actually one of them. I hope you all feel like you are learning a lot about the science from the presentation so far. But there were, as you might notice from this snapshot from 2014, the idea of social media, new, maybe something to try. There's a lot of areas for growth in how information is distributed to various audiences. And there are a lot of ways that you can think about trying to match up which of these ways of communicating can reach which audiences. Are there multi-purpose areas you can focus on where maybe the primary intended audience for something is going to be this group, but if it is well done and effectively designed, then you could maybe have it also apply and reach other groups as well. And so this is all in the works of being updated, and I am going to, in the next few weeks, be sending to the steering committee a newer version of thinking about the strategy for 2025. And if anyone not on the steering committee is also interested in seeing that for the RMP, I encourage you to chat with me after. But for now, I wanted to share with all of you a little bit about some of the directions that we have been taking in the last few months and are considering expanding into in the coming months. So just a couple of highlights. This is not an exhaustive list, but I do want to recognize that there is a lot of feedback loops between the different ways that you can communicate. And so if you are thinking about adding in one thing, really trying to not make solo one-off efforts that are in their own little rabbit holes, but keeping stuff in a system where communication is building on itself and being able to effectively use partnerships as well to make it go even further. I think that a lot of folks might have mixed feelings about media coverage of science, which is very fair. And so a big goal for press outreach is being able to be much like with monitoring contaminants, anticipatory and not just reactive, and being able to cultivate long-term relationships so that folks are able to reach out and ask questions and get the best available understanding from the best available science about what we do and don't know, and being able to also get ahead of issues where the public might be concerned and being able to help frame those stories with journalists who are interested. And earlier in the year, we had a study come out about forever chemicals, PFAS, in bay fish, and that was covered by a couple of dozen outlets of various sizes. And some of the work that I need to do is being able to get those journalists to also understand what stories are worth covering, what is new, what is unknown. The bounds of science are really hard to translate sometimes for media, but it's really important work to be able to do. And so even though media is not always the best friend of scientists who know that the accuracy is sometimes sacrificed for the public, it is will hopefully always have journalism around in a democracy, and it is and it is our responsibility to taxpayers who care about clean water, to everyone in our society, to try and get the information as effectively communicated as possible. We have a new website, as Tom was kind enough to point out earlier. There are still parts of it that we are going to continue to build out and improve, but it was completed last year, and I encourage folks to check out some of the information on there. We began releasing these quarterly email updates about RMP work a long time ago, and then because of, again, staff capacity, Jay not being able to do 5 jobs at once, the e-updates dropped off a little bit in the last few years, and so I'm able to make sure those are coming out consistently now every 3 months, and also being able to add more content to them. And based on feedback from last year at the annual meeting, we know that this is a way that a lot of folks rely on being up to date with what we have happening throughout the year. We have grown our social media a lot. The RMP does not have its own personal accounts. We post updates from the San Francisco Estuary Institute accounts from time to time. And we've added a new platform, which is Blue Sky, a replacement for Twitter. We have so I'm going to actually skip ahead one really quick. We have this magazine, which some of you who've been around for a while might remember, called Estuary News. It does not exist anymore, but it did have some more understandable, less technical articles about the RMP's work in it. And I'm a writer by profession in a lot of my work prior to joining SFEI, and I am working with some of the scientists to be able to try and more effectively write about some of the work that's happening. And then there are ways to try and have that have a broader reach, like partnering with the nonprofit water news aggregator, Maven's Notebook. And then finally, the note of soliciting feedback. I'm being told that my time is running a little bit low, and so I would encourage folks to either take a snapshot of this, or I think we can just include it after the meeting as well, so that we don't need to spend a ton of time waiting on this screen, because I want to use my last 1 minute. Perfect. Because I want to use my last 1 minute, as I promised, to revisit this question of audience, about why we care about reaching beyond the folks that are in this room, and why it matters to have our science getting to broader audiences. And I think that all of us are in this room, in this profession, because on some level we are invested in trying to have a better bay with a more accurate understanding for future generations. The RMP Steering Committee a couple months ago had a very spirited discussion about what the real purpose is of trying to invest our time in communication that not only reaches managers, but also makes it to the broader public. And I hope that the broader public of today, the younger generation, will become, the people in these seats in the future, in future years. And because everyone in this region will hopefully be able to recreate in a cleaner bay someday, in part because of the wonderful work in science we're all doing, I hope that we are able to make some meaningful advances in getting that science to reach more people as we're doing it. So I'm available for any questions and welcome suggestions, and will be transitioning to the panel now. Great. Thank you all.
Okay, everyone can come up and we'll do some Q&A. speaking of spirited discussion, I know, Jim, you had your hand up for a couple of panels and or a couple of speakers and we got cut off, so why don't you start?
You know, I did some of this stuff. So in 1990, I started, I'm here to give kudos to Xavier and tell him to move faster. And I'll tell you just a little bit of the story. So I did beneficial use at the Port of Oakland for 15 years. And he knows what happens when you do work on beneficial use. You lose your hair. But so I'm glad to move that on to somebody else. But it's pretty clear in terms of the physics that if you place material in the right place, it's going to go into where you want. And so I was the regional board's representative to BCDC, and I convinced Barry Nelson, who had been Save the Bay guy, to support the idea of placing material in the bay because it would actually go where you want. And there's a prototype out there, which is now being worked on, which is Emeryville Crescent. Emeryville Crescent is a habitat for endangered species that was created by dumping material from the original construction of the Bay Bridge sideways. I found pictures in the Port of Oakland's archives of the mounds that were created. That was Merritt sand. It moved there, was sorted and created habitat for what was then the Clapper Rail and is now the Ridgeways Rail. So keep it up. Thank you. You know, the regulatory scheme from the regional board as a former board member has been a little too tight, and I appreciate what Xavier has done to make it better for habitat. Thank you.
I have a question for you, Sam. Again, compliment what Richard brought up. You know, it's a dense subject that you had to condense for this audience. So, but as you know, I got some insight to some of the details, and so I want to be careful about asking a weedy question in front of everybody because I'll engage with you more on this. But you said something that got my attention at the end, and it was a bit of a flash, where you're saying the optics results corroborated reasonably well with the model results. That took me somewhat by surprise.
Yeah, maybe I should clarify. The data that we have collected during the optics monitoring period corroborates what we were using in the modeling. We have not gone through the full PCB flux estimates and loadings estimates that we have. So the samples that I was showing there were just concentrations from the water samples, but they corroborate what we've had in the past.
Okay, thank you for that clarification because you know,
Yep.
it's a great piece of work. It's still a work in progress. So I was sort of like, whoa, that seems premature to claim success. Or you can't fail because it's going to give us information and knowledge that we can adapt in terms of improving our models, improving how we monitor from here on. So you're in a good situation to not fail.
No wrong answers.
Other questions? Oh, Ellen. Hi, Ellen.
Thank you. Hi, Xavier. It's good to see you not in a small box on Zoom. And I like your hair. I've got a question, though. Do you know if Carquinez Strait was part of the dredging project and between the years of 2020 and 2023?
Not part of the Army Corps dredging.
That the slides that you showed, right, where you said you guys were sort of partners in the background with them and they did this dredging, do you know if the Carquinez Strait or that area at all was part of that?
You mean, it wasn't, which pilot study are you talking about?
Okay, so.
There's the Oakland 50/50, so that took it from the Oakland channel.
Right.
And then the strategic placement was from Redwoods, the Port of Redwood City to Eden Landing.
Okay, and then they had some portion, I think, of the San Francisco to Stockton as well, right? Because I know there was a lot of protesting kind of going on in that area, but we did see some type of dredging, and since you mentioned the transferring of the soils and what have you, I'm just wondering if you know if it was part of that project.
So it's part of dredging Pinole Shoals, so right through Carquinez and in Sassoon Bay and dredging Sassoon is part of the core maintenance dredging program, but it wasn't part of those pilot projects.
Okay, so none of that occurred in that area between 2020 and 2023?
Well,
That would have included the area?
dredging occurred there, yes, but that was disposed, I'm trying to remember where that, I believe that was sent to deep ocean.
Okay, I thought so, okay. And then my second question was for Sierra High. When you mentioned about the importance of communication and how you guys go about, you know, communicating, developing those relationships, and it's not a bad, but my observation, I don't think I've seen a Black person in any of those visuals, and that is very important. And then when I look around the room, I think, without trying to judge anybody's ethnicity, but it may be 3 of us in the room of 100. So I'm just wondering, how do you guys intend on filling that gap? And especially with me being a part of that population that our current administration seems to think out of sight, out of mind, what efforts are being made to really ensure that not just the younger generation, because we have to train them, but that we all in this room take that serious. When I look to the left or right of me, if I'm not seeing a certain group, I would be asking those questions and making those a priority.
I really appreciate the question, LaDonna, and it's great to see you in person as well. I don't think that I am equipped to talk about SFBI hiring, but I can speak more broadly to this is a really challenging time with the way that, I mean, you know, different groups of people and different aspects of science, and just a lot of what we seem to be moving in a different direction, seems to be moving kind of in a very different way than a lot of folks expected, and that is challenging. And I know that SFEI, as you know, as the Institute, is still really committed to working with all of the community partners and trying to do the science as best we can and trying to keep our partnerships alive as best we can. And it's definitely a top priority, but it is a challenging time to do that. And I think that there are other folks maybe a little higher up than me that could probably speak to some of the longer term planning and strategy around how to navigate that.
Thank you. Did you have a question?
Great, thank you. I'm Ellen Jonk. I'm an environmental cultural resources consultant, a pioneer founder of RMP back in previous to 1993. So I liked at this point, like Jim McGrath and a few others in the audience, like to connect the dots and thinking about how RMP is the application of it can be a public service to a wide range. That's wonderful for your new hire, Sierra. So I like to connect between that theme, Stan McWilliams, your modeling on sediment transport, and Javier's call to action on beneficial use, which I've been working on for a long time too, of dredge material. So the city of San Leandro, Army Corps of Engineers used to dredge San Leandro Bay. And we took the sediment, we created a beneficial use site right there along the land side. And things were going well for a while, and I won't get into where we are now. But the status is there's no more dredging of San Leandro Bay. That wetland restoration site that we did, that's closed, but it's been completed. But there's a lot of interest in the city of having a broader commuter service, perhaps a new ferry service into the bay. Maybe it'd be a good idea to talk more about dredging and how we could recreate taking the sediment. Have we looked at the data from PCB concentrations when we were dredging San Leandro Bay? I don't know whether our database goes that far. And what would happen if we allowed another form of distribution of PCB into a new wetland site in some kind of, containment area, or however we would need to evaluate that, and how Sierra can get involved in discussing that in a wider way. So I just think that's something where the application of RMP data and all the missions of our different agencies could get together and thinking about what's could happen in the future. So any comments on that idea? Moving PCBs in another direction, beneficial use, and communicating to the public for a broader transportation service for residents in the South Bay.
Comments?
That's a really cool idea. I would love to have a ferry go down there. And from the PCB side, I think we haven't gone that far back to look at the dredging information or the impacts of dredging on the modeling work or what that might look like. It's something that could be evaluated as a component. There's been a lot of advances in modeling sediment plumes from dredging or from other sources like that. It could be something that we could take into account, but it hasn't been something that we've done so far.
So I'll just add on, I think to do, if the PCB concentrations, I'm gonna guess, I don't know what they are, we'd have to see, but it would probably have to be, there's two types of material that's used for beneficial use. There's surface material, and that can be in the top 3 feet, and then there's foundation material that has to be below. It does highlight one of the needs, and that is for beneficial use sites themselves. Right now we have 2, one of them only accepts surface material, and then one accepts foundation, which is the slightly more contaminated, as well as surface. And so if we had more beneficial reuse sites that could accept foundation materials, then I think, Ellen, that's a possibility depending on what the concentrations are.
Other questions? Yeah. Oh, up there, Karen.
It's actually Karen.
Karen, sorry.
That's okay. I will spin my curse for my entire life. So I have a few questions for you guys. So one is, I know we're looking at beneficial reuse of sediments, but also I want us to think about beneficial reuse of biosolids. Potentially, I know some of the areas in the bay, we need to fill it for sea level rise in the future. So it's something, as a scientist, we need to be thinking about that. How are we going to be protecting all of our shorelines? Could we be looking at, and this is something we've been researching for a long time, we're really smart people, how do we reuse biosolids to potentially fill in some areas to protect, and looking at horizontal levees as our future? So.
Could you do me a favor and define biosolids?
Okay, Class A biosolids from wastewater treatment plants.
Thank you.
Okay, because yes, we are not going to give you Class B, Class A biosolids. Sorry, wastewater treatment plant folks, I will be giving him Class A. What's the difference? Oh, Tom.
Let's just answer the
Can we just
in a
go?
general.
We
in a
can
general,
talk about that at
in
lunch,
a general
people,
sense.
over our food. If you really want to talk about biosolids, we call it sledge cake. We can also have all sorts of fun talks about that kind of stuff at lunchtime. Yeah.
So the biosolids are less than 1% of the need for fill, so it's not a focus of the water board. There's a lot of regulatory constraints. There's also a lot of science that needs to be looked at. They have used biosolids, I believe it was somewhere in the Gulf of Mexico. I'm going to guess Louisiana or Mississippi. And what they found was it actually increased erosion, because while the marsh vegetation grew rapidly, it was all above ground biomass, and it wasn't developing the root structure that would hang on to the soil. So there are some things that we would have to look at before we would want to use biosolids for marsh restoration.
I'm just saying that we have a lot of biosolids in the Bay Area, and it's also really expensive since we no longer can put it into landfills. So We have a lot of really, really, really smart people in this room, and we need to be thinking about solutions because we cannot put it in landfills anymore due to other state regulations. The other thing is, because we now have a wonderful communications person, how do we get people excited about the RMP? I've been part of the RMP for 20 years. Most people have no idea about the RMP. I hate to break it to you, except for us nerdy science, which is what I love, right? But how do we get the next generation of people excited about it? How do we get the high school kids, the college kids, the people of color, the people that are not represented here? How do we get them excited about the science of what's going on in the Bay and connected to what's going on in the science that's here? Like, that's why we have this vibrant ecosystem. This is what we need to get people connected here. Sierra.
People do actually care a lot about water quality. I mean, it is consistently an issue that, at least on the surface, you ask someone like clean water and they immediately think like, yes, I want that. And so I think that, because the work that we do actually does matter so much for the public's quality of life, it's making those connections much more apparent, because the average person might think sediment has nothing to do with them and might not even actually know what sediment means. But if you are able to get a message, but people do care about, in the Bay Area at least, a lot of folks are very concerned about sea level rise. They're concerned about the futures of what their communities will look like. And so if you can make that connection and have that be something, then you have people interested. And so I think it is doing a better job of connecting why the work that we do, if you zoom out a little bit, is impactful for people's lives and communities.
We have time for one online question and one last question over there, if you want to do the online question first.
Not a question from online, but additional support for representation and communication work, making it a higher priority.
Thank you. And last but not least.
Thank you so much. My name is Ruth Tinacher. I'm a professor at Cal State East Bay. I'm here based on an invitation from Kaylee and Sierra. Cal State East Bay is located in Hayward, California, and we represent the most diverse college campus in the continental United States. Statistically speaking, we have 16% white students, 16%. And I'm here to reach out to you all and find ways to collaborate. I'm teaching environmental chemistry and green chemistry, and we're in the process of setting up a new water analysis course with the hope that our diverse students and graduates can find jobs in the water and wastewater industry. And again, I want to thank Sierra and Kaylee for reaching out and inviting me to come today. Thank you.
Thank you. The future is students. Let's give our panelists a thank you. We've heard about a lot of great science, great new communication tools, and some emerging new regulations that we'll be hearing more about too. So with that, I think it's lunchtime. What time are we supposed to be back in this room? 1:20. Have a nice lunch. 1:20.